this video, we'll conquer our first problem under a grind75 problem set, which is a two-sum problem. So a two-sum problem is a most like problem in LeetCode, so we'll probably run into this problem at some point. And we'll be conquering the solution in JavaScript. So given an array of integers nums and an integer target, we need to return the indices of two numbers such that they add up to the target. So if we look at our example down below, our target is equal to 9, so that means in this nums array we need to find two values that sum up to 9. So by just eyeballing this, we can see that 2 and 7 sum up to 9, so our output would be an array of the two indices, which is 0 and 1. We can also see that in this problem that you can return an answer in any order, so 1 and 0 is also valid in this case. Looking at the other assumptions in this problem, it tells us that you may assume that each input would have exactly one solution, so there's always two values in this nums array that can sum up to a target 9, so you don't have to return any value if there's no matches. It also tells us that you may not use the same element twice. So for example, if our target was 10 and there's only one 5 in this nums array, we can't use that same 5 twice. However, if they're in two different indices, then we were able to use them. So if you scroll down and look at example 3, we have the array 3, column 3. So in this case, we're able to use these values. So you can have duplicate numbers as long as they are in separate indices. Alright everyone, it's time to formulate a solution. So for this problem, there's a very easy way to do it using the naive approach, and that would involve using a double for loop, where you'll loop through and find every combination in the nums array and see if it equals to the target. So for example, we'll first check -4, and then 7, and then -4, and then 2, and then we'll get 7 and 2, which will eventually give us an answer of indices as 1 and 2. This works, but it's a solution of n squared time, which means that as this nums array grows, our solution will become less efficient and will take up more time to run. So we want to develop a faster approach. So we can actually do this with an O of n approach. So let me just wipe out this board first, and then we can find out how to do that. So in order to, with an O of n approach, we definitely have to loop through this array one time. So put a pointer right here at -4 first and call this x1. And then we need to find a number with this -4 that equals the target 9, which we'll just call x2, which we don't know. So we know that the target is equal to x1 plus x2. So in order to find out what x2 is, we just rearrange the formula, so then we get target minus x1 equals x2. We also need some sort of object or a hash map to store the values that we've seen before. So in this map, we'll store the key as the value that we see in this array, and the value can be the index of this number here. So for example, let's solve for x2 here first of all. So x2 is equal to 9 minus 4. So it equals 13. We check if 13 is here or if it's seen before. You can see that this is our first value that we're checking, so 13 is not in here. So that we continue on, and when we continue on, what we can do is we can add this -4 into this object as a key, and we can store its index. Alright, so moving on, I'll just change colors to differentiate it a little bit. So our x1 is now 7. So getting down here, 9 minus 7 is equal to 2. You can see that 2 is not in here. So again, we add this x1 as the key into this object. So 7, and we can make a value of the index 1, and then finally we look through our last value, which I'll make blue. x1 is now equal to 2, so we do have 9 minus 2 equals 7. And looking through here, we see that 7's in this object, so that we can pull this index here and construct our array that we need to return. So that will be a 1 here, and then while we loop through this, you already have the current index of this 2 stored, so that will just be 1 and 2, and that will be our final answer. So before I begin coding a solution, I just want to explain that I'm going to be using the map object that's built into JavaScript itself. And the reason why I'm using this over the traditional object in JavaScript is because with a traditional object in JavaScript, the keys can only hold strings. So if I use the traditional object, I have to convert back and forth between strings and numbers in my solution. I don't want to do that, so that's why I'm using this map. So map is very easy to use. I'm going to be using a couple of the set functions. So for example, the set function, I'll need to use that one to put values into the map. I'll need to use map.get to get the values. And I'll also need to use this function has, which returns a boolean indicating whether an element with a specified key exists or not. Alright, we can finally start coding out our solution. So the first thing we'll need to do is we'll need to set up our map. So we'll say let map equal to new map. And because this is an O of n approach, we'll need to look through our nums array at most one time. So that's O of n, and that means we need to do one for loop. So for let the index of x1 equals 0, index is less than nums.length, index plus plus. We can first set up our x1 value, which is just nums of index, and then x2, as we formulate, is target minus x1. So the first thing that we have to do is we have to check whether or not x2, the key, exists inside the map. So we can say if map.has x2, then we can return our answer, which is current index of our loop, and also the index of x2 that we've seen previously, which is going to be like this. So map.get gets the value or the index of a key of x2. And if we haven't found a solution yet, we go on and we store the current value that we're looping through as a key, which is going to be x1 here, and then its index, which is just idx. So I'm going to hit submit. And we can see that our solution has been accepted.